Hello everyone, today we're looking at the next 14 questions from that ENGAA paper that I did in the last video, and this is questions 15 to 28 from section 1 of ENGAA 2017. These videos are centered around the ability to do these multiple choice maths and physics questions at a great speed, which is applicable both to section 2 of the BMAT as well as the ENGAA itself. Let's begin. So, there are 100 students in year 10. Each student studies exactly one of French, German, and Spanish. X girls study French, and there are 3 X girls in total. 2 Y boys study German. 35 students studying Spanish, of which Y are boys. Okay, so basically we have the conditions French, German, or Spanish, and it can be boy or girl. And what I'm drawing here is something that I call a contingency table. You'll be able to draw it faster in the real exam because the area is not so big, right? But anyways, X girls study French, so you have put X here. 3 X girls in total, so total girls 3X. 2 Y boys study German, so 2 Y here. 35 students studying Spanish, of which Y are boys. So 35 studying Spanish, Y boys. Which of the following is an expression for the total number of students studying German? Okay, so you want this. You know that there are a total of 100 students, and so that means this is 100 minus 3x, because these two add up to 100, and then this is 100 minus 3x minus 3y. Well, that doesn't really matter. Actually, no, it does matter. So this must be 100 minus 3x minus 3y, because you add these up to get this one, and adding these two up, you get 100 minus 2x minus 3y. And if you add these up, you get these three are equal to 100, so cancel 100 from here, and you get 35 minus 2x minus 3y plus question mark is equal to 0. So that means question mark must be 2x plus 3y minus 35, which is right here. So the key here was realizing that there were only a certain number of possibilities, and that all of these possibilities, in a way that is easier than a Venn diagram, could be expressed in this kind of contingency table. And this is quite useful because it allows us, with the simple rules that the columns here must add to the total here, and these 3 totals add to here, and these 2 totals add to here. With these simple rules, you can use contingency tables to a great problem-solving effect, like in doing a Sudoku, for instance. So that's sort of how they are applied, and it means that each step of the calculation is very clear because we know which boxes we need to fill, and we know exactly how to fill those boxes. So 2x plus 3y minus 35 is our final answer. By the way, for question 9, or question 6 it might have been, question 6, my answer was wrong. It is not 9, it is 16, because as one commenter correctly pointed out, we also need to account for the 7 kilojoules of energy lost to the surroundings by the inefficiency of the motor, but I did not account for that. Anyways, back to the questions. The radius of an iron-56 atom is 30,000 times denser than the radius of a nucleus. What is the value of density divided by density? Okay, so density is m over v, m over 30,000 v, because we're taking the electron mass to be about 0. Cancel, 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 cancel. 30k, because this is 1 divided by 1 over 30,000. So 30,000, 30 times 10 to the 4 to the power of 1. Oh, no, this is radius. So since volume is proportional to radius cubed, it's to the power of 3. So as the volume of an iron... No. I've got this wrong again. I've been going too fast and not reading the question properly. The density of the nucleus is on the bottom. So this 30,000 cubed term is up here. And so we want 30,000 to the negative 3. This is the answer. So density of iron atom, which has a V of 30,000 cubed V, where the nucleus has a V of just V. This is a ratios and proportions question. That's based on the idea that density is this m over v idea, and volume is proportional to radius cubed. So I don't really have specific tips on doing this quickly, other than simply knowing that rho is m over v. You don't need to write rho, you just write m over v with some number here, and m over v, and then doing the cancelling should come quite naturally. If you have two fractions, if you have some fractions above and below a fractioning line, then if you have two numerators above and below, they can cancel. And if you have two denominators above and below, they can cancel. And that's quite a useful rule. An exterior angle of regular polygon with sides n is 4 degrees larger than the exterior angle of regular polygon with n plus 3 sides. Okay, so with sides n, the angle is 360 over n, and this must be 4 plus 360 over n plus 3. Now, one way to do this, obviously, would be to solve a quadratic, but I think that's a waste of time. I actually did this question next to a friend in real life, and we were talking about fast ways to do this, and it turns out the fastest way, you may have noticed, is just literally going through all the answers. So, could it be 10? So 360 over 10 is 36. 360 over 13, oh, that's going to be some ugly decimal number, so we already know that's not right. 360 over 12, that's going to be 30. 4 plus 360 over 12 plus 3 is 15. 360 over 15 is 24. So 30 is not 4 plus 24. This is, again, wrong. And what about 15? So 360 over 15, that's 24. And plus is equal to 4 plus 360 over 18. Well, this is 20. 24 is 4 plus 20. Absolutely right. So again, that's one of the things you ought to keep in mind. At some points, it can be faster to just look at each of the answers and try them individually, rather than going through all the hassle of solving this quadratic equation. And I think that's really what the question is asking you to do, because this is so much faster for this particular question. It might not be faster for every question, but that's, I don't know, it's still advice to keep at heart, to keep in mind. Graph 1 shows how the displacement of one of the particles of a medium varies with time, and graph 2 shows how displacement varies with distance in meters at one time for the same wave. Okay, what expression gives the speed in meters per second? Well, if v is equal to f lambda, I don't know, this is quite annoying. F lambda. We know that this distance, x2 minus x1, is half a wavelength, because a peak to a peak is one whole wavelength, so we know that lambda is 2x2 minus x1. And what about f? What about the frequency? We know that for it to pass through, for this one particle to pass through one entire oscillation, it takes this much time. So t2 minus t1 is 3 over 2 times the period. And as the period is 1 over the frequency, we get 2 times the frequency is 3 over t2 times t1, and the frequency is 3 over 2 times t2 minus t1. So if we multiply this fraction by this fraction, then this cancels out, these two cancels out. Notice how I am deliberately not writing the whole thing out again to save time. And this It's just the fraction that appears in every answer with a 3. So let's see if they have it. Yes, they do. The key things to do this question quickly was to notice that every answer has this particular fraction involved, so you know that you're looking for something in that form. The only difference is being on the numbers beside them. So having figured out that this lambda was 2 times this thing, and having figured out that the frequency was 3 over 2 times this thing, 3 over 2 times the, or divided by the time, means that we just need to realize that this 3 over 2 times 2 becomes 3 itself. We did not have to do any extra algebra, even though I did write a little perhaps too much. We didn't have to do any extra algebra to get the answer to the question. Right, let's continue. The bearing of a ship R from a lighthouse L is 220. Now, one thing about bearing problems, you want to draw them out, without a doubt. It's always useful to draw them out. And it's always useful to draw each one with this cross, because then it's very easy to identify the angles you want. So 180 and then add another 40 degrees, 220. A canoe C is due north of R. C is the same distance from the ship and from the lighthouse. Okay. So that means this side is equal to this side. What is the bearing of L from C? Well, that's why I like to draw these crosses, because we can immediately say, like, oh yeah, so if L is 40 this way, then because these two cross vertical lines are parallel, that means it's 40 this way. And since this is 40, this must be 40, because it's an isosceles triangle. And if these two angles are 40, compared to the vertical here, then that means this angle must be 80 degrees. And so the bearing is 080. So the key was to draw, for bearings questions, a plus sign, or a set of axes, a vertical and horizontal line that you can easily use as a reference point or jumping off point to transfer information about angles between different points, like realizing that this is 40 because this is 40, realizing that this was 80 because this was 80. So the answer is B. A kettle is designed to work from a car's power socket. The kettle has a power rating of 150 watts with a constant voltage of 12 is applied across its element. How much charge passes through the element of this kettle when the voltage is applied for 20 minutes? Okay, so P is V squared over R. Or really, no, we have P, V, and we want I. So I is P over V is 150 over 12. And then that's for 20 minutes. So 150 over 12 times 60 times 20 minutes. 60 and 12 cancel to get just 5. 150, 5 and 20 cancel to get 100. And what's 100 times 150? Well, 150, 100, or 15,000 coulombs. So the key here was not bothering to do any of the calculations right until the very end, because a simple simplification was possible. And the other key here was to notice that you are only working, basically, with 3 quantities. It should be completely intuitive to you that X current for 20 minutes is equal to the current times the number of seconds in 20 minutes, right? And finally, you don't need to calculate the number of seconds in 20 minutes, it's just 60 times 20, because of that canceling that I mentioned earlier. You also need to have remembered very well your power is voltage times current formula in order to answer this question quickly. Alright, next question. The hands of a 12-hour analog clock move continuously. When the time on the clock is 4, the angle between the minute hand and the hour hand is 120. What is the angle between the two hands at 440? Okay, so the minute hand is here, but now it goes to 2/3 of the way around the circle. So this is bearing 240. And then if you break this quarter into 3 pieces, you have the 3 o'clock here, the 4 o'clock here, and the 5 o'clock here. 2/3 of the way to 5 o'clock from 4 o'clock is 2/3 of the way from 120 to 150, or this is 140. And so the angle you get here is 100 degrees Celsius. I mean, degrees Celsius, 100 degrees of angle. Okay, that's pretty funny. So, again, similar to the bearings question, it's useful to draw out this diagram so that you can understand the question easier. And it's also useful to think about the fact that a clock's sort of turnstile is very easily divisible into the 360 degrees. So just by rule of thumb and sort of knowing how a clock works, I don't think I can give any particular tips to do this question faster except for draw it, because that is a very useful way to visualize the whole problem. And it allows you to keep answers in your memory on the page. Okay, a freight train traveling on a straight horizontal track at 2 meters per second collides with a passenger train traveling at 5 meters per second in the opposite direction. Both trains immediately come to a complete stop on the track. The freight train has 3 locomotives of 130 tons each and 7 container wagons of 30 tons each. The passenger train has 2 locomotives of 70 tons each and a number of passenger carriages of 10 tons each. Okay, so because this is mechanics on the big scale, collisions on the big scale, we use the principle of conservation of momentum rather than conservation of kinetic energy. The mass of the freight train, 3 of 130 tons, so 390 tons, and 7 of 30 tons, so 210. In total, that's 600 tons of mass. And the freight train is traveling at 2 meters per second, so 1,200 ton meters per second. The passenger train has 2 locomotives of 70 each, 140, and a number of passenger carriages at 10 each. So basically, this times 5 must be equal to 1,200 ton meters per second of momentum if they want to cancel out, right? So if this is 240, which is 1,200 divided by 5, 140 and 240 cancel out to get 100 on this side, and so it becomes obvious that n is equal to 10. There are 10 passenger carriages. So the key to do this question was to immediately identify that because we're working on the big scale rather than small scale, the principle of conservation of momentum is the most important physical law to think about, and to realize that the momentum of the first train must equal the momentum of the second train, in addition to all the arithmetic tricks that we used. Notice how I hardly wrote down any full equations. I was just writing down random numbers and canceling and rewriting as I saw fit in order to answer the question. This ideally is what you want to do in the exam, given that these questions are quite short, especially for the BMAT and the ENGAA in the first section. If you are doing a harder physics exam, like the second half of the ENGAA or the PAT, then it is advantageous to write out your working in a way that you can understand later when you forget what you were doing. But for shorter multiple choice questions like this, you do not have to. A pet shop has 4 female rabbits and X male rabbits for sale. Customer buys 2 chosen at random, and each rabbit is equally likely to be chosen. The probability that both are male is 1/3. Okay, so I think we could try doing this with trial and error, actually. So my intuition is because if you have 4 female and 2 male, then I don't know, actually that doesn't seem right, because there's only one possibility for two male rabbits. If you have 4 and 4, there's okay, so I'm guessing that the number of male rabbits has to overwhelmingly be overwhelmingly greater. So let's start looking at around 8, for instance. It's 2/3 for the first rabbit times 7/12 for the second rabbit. So 7 over 18. That's just a little bit more than what we want. Oh, 7 over 11, sorry, because there are less rabbits. So this becomes 14 over 33. And that's more than 1 over 3. So now let's guess with 6. 6 male rabbits, you have 6 over 10 to choose the first male, and then 5 over 9 to choose the second male. Cancel, and we get 6 over 18, which is 1/3. Excellent. So the answer is 6. What we did, because all of these answers are basically in sequence, this is the exact same kind of problem as you might know as a balls in an urn problem. So as in, if you have X red balls and Y blue balls in a pot, what is the probability that you get a certain arrangement of these balls, right? It's the kind of classic tree diagram probability question that you would be asked on an earlier math exam, or just the BMAT or the ENGAA in the first half, right? So what we did is we saw intuitively that 2 rabbits would definitely be much less than 1/3, because there's only one possibility out of something like 15 ways you could pick 2 rabbits out of those 6. But we also saw that 12 must be too much, because 3/4 times roughly 3/4, that's a number that's not close to 1/3 either. So, because we knew that there were going to be many ways to pick 2 rabbits, and it would be like 3/4 for the first rabbit, and then approximately 3/4, but a little less for the second rabbit, right? And multiplying these together, you get 9 over 16. Generally, in your head, you wanted to have realized that this is slightly more than a half, and is certainly not the number we're looking for. So I thought, why don't we start in the middle then? 8 was too high. The probability of getting 2 male rabbits was too high, and so we tried 6, and that was correct. So our educated guess was not far off from the truth, and that's what you want to do in a scenario like this, where I think finding the actual number of male rabbits would require you to solve some quadratic equation like x over 4 plus x times x minus 1 over 3 plus x is equal to 1/3. Like, this is possible, but there's no reason you'd have to do it. It's better to just do trial and error with these kinds of questions. Now let's move on. 5 questions to go. Consider the following 3 statements about the parachutist of mass 72 kg falling at a constant velocity after the parachute has opened. The parachutist has a constant kinetic energy of 1800 kilojoules. 1800 joules, is that right? Okay, falling at 5 meters per second, v squared is 25. Half m, half of 72 is 36. 25 times 36, let's see. This is 9 times 4, so 25 becomes 100, and it's 900 joules. So this is incorrect, because the kinetic energy of the parachutist is 900 and not 72, and not 1800 joules. The parachutist is losing gravitational potential energy at a rate of 3600 joules per second. If delta E is mg delta h, and the rate delta E over delta t is going to be mg delta h over delta t, which is 5, g is 10, m is 72. 72 times 50, 3600 joules per second. That statement is correct. And finally, air resistance and the force of gravity acting on the parachutist are a Newton's third law pair of forces. Okay, this is hard to think about, I think, actually. No, I would say that it is not, because the third law pair is the Earth being pulled towards the parachutist by the force of gravity. I would not say that the air resistance is Newton's third law pair of forces, because I think the third law pair to air resistance would be the force that the skydiver exerts on the individual air molecules through their electrostatic deflection from the molecules of the skydiver, and vice versa. Whereas, because those are both electric forces that act upon each other, but the skydiver's force of gravity, the skydiver's weight, is gravitational force that is complemented by, in the sense that it's the force between the skydiver and the Earth due to gravity. The skydiver is experiencing skydiver is experiencing about 720 newtons of force towards the Earth, and the Earth is also experiencing 720 newtons of force towards the skydiver from Newton's force gravity equation, you feel? But that's basically why 3 is not correct, at least as far as I think, because Newton's third law pairs can be quite tricky. Anyways, if it gets down to it, just guess one of these 3, because it may be worth your time to spend it on the other questions if you do not fully understand Newton's third law pairs. Okay, so let's move on. Question 25. The diagram shows a square with side length x. A circle is drawn with center O. At the midpoint of one of the sides of the square, right? The side forms part of a diameter of the circle. So this is x over 2. Part of the diameter of the circle passes through the 2 corners of the square as shown. What is the area in cm squared of the shaded part of the semicircle? Well, this is r. I think we'll calculate the area of the whole circle, so it'll be pi r squared minus x squared, or pi over 2r squared, which is this semicircle, and then subtract the square from inside. So what is r? If you have r, x, and x over 2, this is a 1 over 2, and root 3 over 2 triangle, because it's like a, oh, no. This is root 5 over 2 by Pythagoras. One thing to consider here is that this is like a 2, 1, root 5 triangle, all divided by 2. So you don't actually have to calculate that, oh, it's 5 over 4 and square root of 5 over 4. You can just think of this triangle as an extension of this simpler one to get the hypotenuse. But anyway, knowing that r is root 5 over 2, you get pi over 2, and you don't even need to calculate r, to be honest, because you're just looking at r squared in your final answer. So r squared is a 1 plus half squared, right? You don't need to square root it at all. It's 5 over 4. Pi over 2, 5 over 4, minus x squared. Or 5 over 8 pi minus x squared. So what is the area of the shaded part of the semicircle? It's this, because that's the only one that has a term of 5 over 8 pi. They've done it in a bit of a weird way. Oh, right. This is 5 over 4 x squared minus x squared. Yeah, no, they haven't done it in a bit of a weird way. This is just a kind of pretty appropriate way to factorize the whole thing. But anyway, even though I was wrong mathematically at the beginning, I still got the right multiple choice answer because I recognized that 5 over 8 pi was the pi term involved. So yeah, anyway, now that we've gotten this, let's move on. 25F. Yeah, this is a pretty satisfying question. 2 radioactive sources, X and Y. Okay, just to reiterate, the strategy I used here is first, we notice that R is a necessary quantity, and we find this expression for the area. It's pi r squared minus x squared, because you're looking for the semicircle minus the square. In these shaded area questions, it's usually a big shape minus a little shape. 2 radioactive sources, X and Y, have half-lives of 3 hours and 2 hours respectively. The product of decay of both of the sources is Z. 6 hours ago, a mixture contained the same number of atoms of both X and Y, no other atoms. What fraction is now Z? Okay, so X, Y, let's do it in 1 hour increments. 0, 1, 2, 3, 4, 5, 6. X has a half-life of 3, so if you start with 8 atoms of X, then it goes to 4 atoms, then 2 atoms. And if you start with 8 atoms of Y, it goes to 4, then 2, and then 1. So 3 atoms of the original are left over from 16, so that means 13 over 16 are atoms of Z. The key here is that, again, there's no mathematical trickery needed. It's just that simply writing out a table is the fastest way of dealing with this kind of question when you have a radioactive isotope related question. The half-lives of 3 and 2 in a 6-hour period is also a helpful sign, given that these are all in factor terms related to one another, those kind of numbers that sort of fit together well. So you know that it would be a good idea to simply draw it out in a table because all of the half-lives fit neatly into the total time. A cylindrical hollow metal pipe is 16 centimeters long. It has an external diameter of 10 centimeters and an internal diameter of 8 centimeters. The density of the metal from which the pipe is made is 8 grams per cm. What is the mass of the pipe? So it's the big cylinder minus the little cylinder. A cylinder is base times height, or pi r squared times height. If it's pi r squared times height minus, or pi big R minus pi little r, then this r squared is going to be 5 is 25 times a height of 16 minus 16 times a height of 16. And 25 minus 16 itself is going to be 9, so it's pi times 9 times 16, which is 9 times 16, 3 times 4 squared, 12 squared, 144 pi. Ooh. Oh, 144 pi is the volume in centimeters cubed, and we want 8 grams per cm cubed. 144 times 8, that looks like it's approximately this. Let me just think if that's correct. Yeah, it's correct. So, yeah, this is, again, a pretty standard mathematical question. What you needed here is you need to have faith in your own calculations. If it suggests that it's 8 times this quantity, then it ought to be 8 times 144 pi is going to be about that number, about 1,152. So I think from this point, you can pretty much circle the answer G and walk away, because as long as you are confident in your initial calculations about the volume of the pipe and the mass of the pipe, you can think to yourself whether there are any other steps you've missed, as I did when I saw that 144 pi was not an option, and then move on to go like, yes, this is exactly what I'm looking for. And finally, for the last question, car X passes car Y on a motorway. Car X is traveling at 1.5 times the speed of car Y. The mass of car X is 4 over 5 the mass of car Y. Okay, 1.5 times the speed, 3 over 2. K is proportional to V squared. How do the kinetic energies of the two cars compare? It's proportional to V squared, so X has 9 over 4 more V factor. The mass is 4 over 5, so it has 4 over 5 times the mass factor. So it must be 9 over 5 times the kinetic energy of car Y, or option E for 1.8. So overall, this is just another ratios and proportions question. The simplest way to think about it was not by writing down any symbols denoting the energy of X or Y at any time. It's just that intuitively you can tell through proportionality statements like if the v is 1.5 times more, then ke must be 1.5 squared times more, and if if it's proportional to m, then 4 over 5 m makes 4 over 5 e, right? So you just write these down, and through cancelling without writing any other additional detail, because as I said in previous videos, now is not the time for fine detail, now is the time for speed, so that you can spend more time on the latter questions if you're taking the ENGAA, or you could just like actually finish the paper if you're taking the BMAT. This kind of scribbling is enough to help you come to the solution. So anyway, there are no more questions that I'd like to cover in this video. I will probably not be covering the Part B questions for the ENGAA because it loses the applicability of the videos to the BMAT, and this series is a support material for both. If you found that this video helped you, please be sure to subscribe to the channel and share the channel with your friends so they can be helped too. Until next time, many thanks. This is Watch Me Do Math.